We're recording day 12 lesson part 1. It's going to be on static electricity, charge, charging, and electric force. Charge is just a fundamental property of a matter, a piece of matter. So sort of like mass is a fundamental property, charge is as well. Q is the symbol for charge. All matter has charge in it. So it comes down to the particles that make up matter. So in atoms, you have protons, electrons, neutrons. Protons and electrons are the ones that are charged. And because atoms make up all matter, there's charges in everything. An object is imbalanced in charge when you have unequal amounts or different amounts of protons and electrons. The idea is that if you have equal amounts of positives and negatives, they're just canceling each other out. But when you have unequal amounts, you have more electrons or more protons, you would have some total charge because of that. The law of charges it describes how charges interact. Like charges repel and unlike charges attract, sort of like poles on a magnet. So if you've ever played with like north and south poles on magnets, it's the same idea. I drew up here some pictures to help you kind of remember with that. So if you had two positive charges, they would repel. Two negative charges, they would repel because they are like. And then if you had a positive and a negative charge, they would attract because they are different. The law of conservation of charge is just an extension of the law of conservation of matter, which says that matter can't be created or destroyed. Same idea with charge. So charge can't be created or destroyed. It can only be transferred from one object to another. This example is talking about how charges will redistribute themselves if you have two charged objects, how the charges will move. So let me take you through this example. I'm going to kind of simplify this a little bit and just say, let's say this object is +3, so it's got 3 protons on it, and this object here are 3 extra protons, and this is a -9, so it has 9 extra electrons. So I'm going to make those negatives here now. So we have 9 extra electrons. And let's say that somehow we would bring these two objects together and have them touch so that the charges can move from one to the other. Now, the charge that's going to move is the electron because the electron is allowed to move. If you try to move a proton, you get a nuclear explosion, so that's no good. That's not what we're talking about. We're talking about electricity, so electrons are the things that are going to move. So the electrons are going to move, and if you had 3 extra protons here, then electrons, they would continue to move over until we get a balanced kind of effect. So if you just move 3 over, this would be 3 electrons and 3 protons, so they would kind of cancel each other out in terms of the amount of charge. So that would have 0, and then there's still -6 over here. So if there's -6 over here, that's still not going to be balanced because you would have 0 and -6. So it's going to continue to send more electrons from one to the other. So we're going to keep moving electrons, and eventually you would end up with 3 on the left and 3 on the right. So 3 extra electrons here and 3 extra electrons here. So this sheet, which is in the content area of D2L, you're going to work on and kind of figure out how this works a little bit better. So just by practicing, this takes you through another example. So you got a +12 and a 0. Again, electrons would move, so it's actually going to move the other way, but you can think about like it's just going to try to balance each other out. So if this is +12 and this is 0, it's going to end up with 6 and 6. And when you try to pull them apart, they would end up with 6 and 6 because that's what it would redistribute as. So just looking at the law of conservation of charge, because that has to be kept true. The net charge before is 12 because 12 + 0 is 12, and then afterwards it's 6 + 6, so that's still 12 too. So you're going to fill this out and then come up with an equation to do that, and we'll later on in this video kind of talk through another example, and maybe I'll give you some hints on how to get that, but it's not too difficult. I think you're going to be able to figure it out here. The charge before and the charge after should be helping you answer this question for part 2. So talking about charge a little bit more, we're going to start talking about the electric force equation in a second. So we have to figure out like how charges interact and the amount they interact. And to do that, you need to know how much charge is located in a particular item. So a proton, an electron, they're just positive E and negative E, and this is the value for E. So it's 1.6 × 10⁻⁻19 coulombs. Excuse me. Or if you look at that as a decimal, it's that. So it's 18 zeros and then 1 and a 6. So it's a really small amount of charge, and that's because an electron is a really small particle, and so is a proton. So don't worry about this equation too much. But sometimes you'll be given prefixes like micro or pico or nano for a charge, and you just have to, just like converting like kilometers to meters, you would do the same kind of thing, except you have different prefixes, and that's what those prefixes stand for. So types of materials, we're going to talk about conductors and insulators, semiconductors, superconductors, don't worry about. So conductor is just a material that transfers charge easily, things like metals, and an insulator is a material that does not transfer charge easily, so non-metals. So a wire, like an electrical wire, and again, I'm trying to draw this. So an electrical cord or wire, you know, the plug kind of thing that you plug into your wall. It's really bad, but you get the idea. Inside that wire, if you cut it open, which you should not do, there's a metal wire that goes through the center, and that is a conductor. So that most of the time it's copper, and that's what allows the electrons to flow through it. On the outside of your wire, you have plastic or rubber, and that's your insulator, and that's to protect you so the electrons that are moving through the wire don't travel into you when you touch it. We're going to talk about charging next. So charging, there are two types of charging, charging by contact and charging by induction. So charging by contact, you can read there, it's just transferring one object to another through rubbing off electrons. And the other one is charging by induction, which is the realignment of charges within an object when a charged object is brought near it. So this one is a little more complicated, but we would do demos in class with this, but I had found some GIFs that you can look at. And if you have a balloon at home and you have hair, I can't use my hair, but you can charge a balloon through friction. So which one of these do you think is charging by friction or rubbing? It should be this one where the toddler is rubbing the balloons against the baby's hair and then sticking them to the wall. So you're transferring charges from the baby's head onto the balloon or vice versa, and it gains a charge that way. So we charged it by contact. If you take that charged balloon and take it next to a stream of water that's just dripping down, you bring it close. This will happen at your house too. You get what's called charging by induction. So this charged particles or the charged object here, I don't know if I can draw on here. So let's say it's positive. It is attracting the negative parts of this water. So in the water, there are negatives and positives, and it kind of rearranges the particles so that the negatives become more attracted. Again, the protons aren't moving, it's just the electrons that are allowed to move. So there's protons everywhere, but the electrons, because you bring this positive close to it, it gets attracted, and that's why the water bends. So that's charging by induction, that rearranging or realignment of charges within a neutral object when you bring this charged object close. The last thing we're going to talk about in this video is Coulomb's law. I'm going to check the time. We're still good. So it's the law that describes the force attraction or repulsion between two charged particles. So if you had one positive and one negative, or another positive, two positives, I just drew a positive. So those are your charges. That's Q. All right, so Q1, Q2. It doesn't matter which one you call which. How far they are apart, that separation is your R value. That's supposed to be an R. And then K is just this Coulomb's constant, which is 9 times 10 to the 9th. Q1 and Q2, again, are the amount of charge, and then R is the distance between them. This is essentially like an absolute value equation, so like don't worry about putting in whether it's positive or negative, because we're going to determine how they interact based on the law of signs. So these two, because they're alike, they would repel each other and try to push each other apart. If they were opposite charges, they would attract each other. So that's easier to do than worrying about putting it in here and learning a different rule. So this equation looks like another equation that we talked about, and you have an activity with Coulomb's law where you're going to be figuring out how much force is acting on two charges on FET. So that should be pretty straightforward, and kind of, again, just screenshot your pictures of that. So let's go through an example. In this example, you can read it. It's 0.3 meters apart. You got a positive charge and a negative charge, and they're 0.3 apart. Sorry for the mouse pad, but that's all I got here. And you're going to try to find the electrical force, so that's Coulomb's law, and describe the interaction. The interaction would be pretty easy, so if it's positive and negative, they should repel. And if the charges touch, what's the charge going to be? So we'll go back and review the first thing that we were talking about in the video. So I just, I had that picture there already, but the electric force equation, I wrote it out instead of using the typing to make sure you can see where things are located. So K is just the 9 times 10 to the ninth. The Q1, Q2, again, I don't worry about the positive or negative because we put an absolute value around it. And then we're going to divide by 0.3 and make sure you square it. That's the thing that people forget and make mistakes with. So you should get a number in your calculator that should be equal to this. It might say 2.18 times 10 to the 1, 2, 3, 4, negative fifth maybe. But it should be that decimal. So that's the amount of force. It's not a very big force, but it's there. And then those two charges are going to try to interact in some way. So they're opposites. So opposites attract. So they would pull each towards the other. So this force would pull in and that force would pull in on both. And they have equal amounts, even though they have different amounts of charge. It's the interaction between those charges. So you need both those charges to figure out the amount of force. Finally, to figure out the total charge or how it would redistribute, we're just going to kind of look at the what we did in the beginning of the lesson. So we figure out the total charge between the two of them. So if we add those together, we get negative 6 times 10 to the negative 9. And then it's going to try to divide it as evenly as possible. So if we divide that by 2, this is what ends up on each one. So that's that lesson. I'm going to stop it here so we don't run out of space. So have a good one, and I'll continue with the rest of this lesson in a minute.